A 99% of fossil enthusiasts miss these crucial identification details. Identifying theropods requires forensic attention to skeletal remnants. But we begin our investigation with the primary signature, the dentition. Theropods, the beast-footed dinosaurs, were universally carnivorous. Their teeth were designed not for chewing, but for gripping and slicing. Examine the serrations. These are called zyphodont features. The size and density of these serrations reveal feeding strategies. Consider the curvature. Deep curves suggest rapid, deep penetration bites. Conversely, straighter teeth indicate precision gripping or specialized fish eating. And now that we understand tooth shape, let's explore tooth replacement patterns. Theropods constantly shed and regrew teeth throughout their entire lives. This polyphyodonty ensured a perpetually sharp weapon system was available. In the field, finding isolated teeth provides initial taxonomic clues. But the smallest teeth often belong to the earliest, most basal theropod lineages. A stratigraphy helps date the tooth, placing it within the correct geological context. Comparing features with extant predators offers functional analogies. An enamel thickness and texture also contribute vital information about diet. The overall morphology of the jaw dictates how these teeth function together. But now that we understand dental clues, let's explore the pedal morphology. Claws, or unguals, represent the primary tools for locomotion and grasping. Theropod feet are characterized by three main forward-pointing digits. The size and robust nature of these claws reveal the animal's primary niche. The first digit, often reduced, sometimes bore the largest, sickle-shaped weapon. Hypercurved unguals suggest specialized slashing or pinning prey securely. Smaller, straighter claws likely aided in stability during pursuit or running. The connection points on the phalanges reveal flexibility and stress-bearing. The powerful muscle attachments meant these claws delivered tremendous force when deployed. Trackways provide context, gait, speed, and social behavior indicators. Deep impressions suggest significant weight or immense force applied during propulsion. Sometimes, keratinous sheaths leave impressions adjacent to the bone core. This combination of tooth and claw typology separates major theropod families. The forelimbs, though often less robust, also bear diagnostic claw structures. Three-fingered hands often exhibit claws adapted for grasping prey close to the body. But these forelimb claws stabilized struggling victims prior to the killing bite. Revisiting the teeth, examine the root morphology for subtle evolutionary markers. Compressed, lanceolate roots differ significantly from broader, rounder roots. The preservation quality directly impacts the reliability of these microscopic identifications. A contaminating matrix must be meticulously removed before analysis can proceed. The high magnification reveals micro-wear patterns indicative of diet composition. Once individual features are cataloged, we synthesize them into a taxonomic profile. For example, skull fenestrate structure often correlates with the dental toolkit observed. Vertebral structures, though less diagnostic than claws, confirm the overall theropod body plan. The absence of grinding surfaces definitively rules out most herbivorous classifications. Ere the serrations facing forward or backward. This detail matters immensely. These adaptations paint a picture of speed, power, and highly efficient predation. The powerful tail provided necessary counterbalance for rapid changes in direction. Even diminutive theropods, or basal forms, retain these essential carnivorous tools. And the sheer variety within the theropod group is staggering, yet unifying features remain. But always search for associated elements. Context solidifies tentative identification. A complete foot allows verification of toe proportions and claw insertion angles. Claw rings can sometimes estimate growth rates, much like tree rings. These subtle dental and pedal characteristics chart evolutionary pathways effectively. And the internal anatomy of the tooth root is a robust, unchanging identifier. Museum collections hold the keys to validating these field observations consistently. The tools of identification must be as precise as the features examined. Imagine the entire system working: the foot anchors, the claws grip, the teeth sever. But never underestimate the information locked within even the smallest serration. These remnants are the permanent record of Earth's most successful predators. And now, you possess the fundamental knowledge to begin your own identification journey. The truth of the dinosaurs is written in the architecture of bone and tooth.